All right, let's take a look at some strong acid-base problems. So here we're just looking at reasonably straightforward problems in acid-base chemistry where we have a strong acid, which comes from this list, which is just taken from the GChem website, or this list of strong bases over here, and we're just trying to calculate the pH, the pOH, the hydronium concentration, the hydroxide concentration, which are all really easy to relate to one another. So for strong acid, strong base problems, let's look at this first problem here. The concentration of the strong acid, which is 0.1 molar, is just equal to the concentration of the hydronium ion. And so in calculating the pH, or calculating the proton concentration, let's start there, all we have to do is look at the concentration of H plus, or HCl, and we know that that's exactly it. So that's going to be equal to 0.1 molar. To calculate the pH, all we have to do is take the negative log of the hydronium concentration, so we just take the negative log of 0.1, which is 1. So now we've calculated the pH of that solution. And then if we want to calculate the hydroxide and the pOH of the solution, there's a couple of different ways we can do that. One is we can use this equation, let's say, to calculate the pOH from the pH. So we can take this number from the acid and that we calculated from the HCl concentration, and we can plug it in right here to the pH plus pOH equation and solve. And so what we'll see is that the pOH is equal to 14 minus 1, which is equal to 13. At this point, we can find the hydroxide concentration by just taking the inverse of the negative log. So if we know that, so pOH, actually let me move this over here. So if pOH is just equal to the negative log of the hydroxide concentration, then we know that in order to sort of back that out of the logarithm, all we have to do is take the inverse, which is raising the pOH to, or raising 10 to the negative pOH. And so that will give me my hydroxide concentration. And so we can do that here. We can just say 10 to the negative 13th is equal to our hydroxide concentration. And then we're done with this problem, right? So we figured out hydroxide, pOH, pH, and the hydronium concentration, and we can do that reasonably fast using these equations. And the same thing is more or less true for hydroxide. So again, I know that this is a strong acid, or a strong base, rather, because it's on my strong base list up here. There's sodium hydroxide. The difference here is that we're looking at a strong base, so the concentration that we're given for the strong base isn't equal to the hydronium concentration, is instead equal to the hydroxide concentration. And so that's just 0.1 molar. And then the calculation becomes very similar at this point. We can go about it a different way, because there are multiple ways to solve this. Instead of going directly to the pOH and taking that to go to the pH, we could say, do this a different way and just say, well, we know that Kw is equal to H plus times OH minus. And we just plug in values here. So we know that Kw is equal to 1 times 10 to the minus 14th. And so that's going to be equal to H plus times OH minus concentration, which is given as 0.1. And so H plus is just equal to 1 times 10 to the minus 14th divided by 1 times 10 to the minus 1. And so H plus is equal to 1 times 10 to the minus 13th. And then from there we can calculate the pH by just taking the negative log of 1 times 10 to the minus 13th. So that ends up equaling 13. And then the pOH we can calculate this way. and just say, okay, well, we know the POH is going to be equal to 14 minus 13, which is equal to 1. So we could have done this a different way. So we've solved this for all the different things that we need to, but we could have done this a different way. We could have just taken the hydroxide concentration that's up here at the top and just said the POH is equal to the negative log of 0.1, and we'd have realized the POH is indeed equal to 1. And those are in agreement because they're just different ways of getting at the same thing. So that's how you solve strong acid solutions or strong base solutions for pH or any of these other expressions, POH, H plus, OH minus. They're all expressions of kind of the same thing.